So I'm going to talk to you about the Rutherford scattering experiment, which was an experiment that was done just over 100 years ago, which came up with a new model for the atom, the nuclear model of the atom. What we had was, back in 1897, the electron was discovered, and following on from the discovery of the electron, a guy called J.J. Thomson came up with this model for the atom, which was called the plum pudding model, whereby he thought that they knew atoms were overall neutral charge, and they knew that there were these small particles called electrons that could be removed from atoms and were part of atoms. So J.J. Thomson had this model that was called a plum pudding model because it was a bit like a plum pudding, or like a Christmas pudding type thing, where you've got this big ball of positive charge that was the atom, and then dotted around inside there are these little electrons which could be removed, taken out from the atom, and that's because they had some understanding of electricity and current, and electrons get involved with that. And this model was proposed in 1904 and existed for a while, and people were happy with that as the model of the atom. Then Rutherford came along, and he wanted to do an experiment looking at scattering particles that were passing through atoms. So they also knew about alpha particles. They didn't really understand what alpha particles were, because they didn't know about the nucleus of atoms yet. But they knew about alpha particles, and that certain elements gave off these particles, alpha particles. They knew about the mass and the charge of those particles. They knew they had quite a strong charge and a relatively large mass. They thought that when firing these alpha particles through the atom, if this is your plum pudding model of the atom, that the alpha particles would pretty much pass straight through. If they had enough energy to be able to barrel their way through all the ball of positive charge, they might get a little bit deflected if they happen to pass near an electron, through the attractive electromagnetic force between the positively charged alpha particle and the negatively charged electron. But they would get deflected a little bit, but pretty much pass straight through and all kind of appear on the other side. So this was what the experiment was. They took a piece of gold leaf and fired a bunch of alpha particles at the gold leaf like this, and expected them to pretty much all just pass through and just have a look at the deflections over here. But they weren't expecting anything too big in terms of the deflections, as we've said, because of this model of the atom, this plum pudding model of the atom. However, they did the experiment, and this is what they found. To their absolute shock and surprise, they found that, well, the bit that wasn't surprising was that most of the alpha particles did just pass straight through the gold leaf and were not deflected at all. But a tiny fraction of them were getting deflected through huge angles, even pretty much back on themselves, the way they'd come. And there was nothing that existed in the plum pudding model that was going to be able to make an alpha particle bounce back like that. There's nothing there that could cause this effect of seeing these alpha particles bouncing right back the way they came, or being deflected through these huge angles. So it was at that point that Rutherford realised that their model of the atom was completely wrong, and had to throw it out and come up with a new model. And so he did, and he came up with this nuclear model that we're familiar with. He said that actually all of the positive charge of the atom and pretty much all of its mass is concentrated in one tiny point, and as we've seen, this is not remotely to scale. In fact, that dot in the middle should be much smaller given that size of the atom there. So when you do your scattering, when you fire alpha particles, most of them would just pass straight through because they're not going anywhere near this nucleus in the center. But on that odd occasion, when you happen to get near to the nucleus, you can get these big deflections, almost pretty much back on yourself, because you've got a very large positive charge in the middle, where the nucleus is. If an alpha particle comes into that, it will be repelled by it and reflected back the way it came. So it was that scattering experiment, these results, that was done in 1911. It was those results there, seeing these alpha particles being scattered right back the way they'd come from this gold leaf, that led to the development of the nuclear model of the atom.